Fellow stargazers, welcome back to AstroKHamp. Today we're talking about something huge, literally. The sun is expanding, you know that? And yep, it might swallow Earth. Hell yeah!
But relax, it's not happening anytime soon. We've got a few billion years to figure that out.
So no need to start packing just yet. But before we go to the main topic, let's talk about an exciting event that just happened recently, which is an annular solar eclipse. So, just a few days ago, on October 2nd, we witnessed an incredible annular solar eclipse, also known as the Ring of Fire. Let's take a look at some of the footage shared by some fellow amateur astronomers who captured this event.
That was amazing, but what exactly is a solar eclipse? Let's break it down. A solar eclipse happens when the moon passes between the sun and the earth, blocking the sun's light.
So there are three main types of solar eclipse. So first, let's start with the total eclipse. Total eclipse happen where the sun is completely blocked, while partial eclipse happen where a part of the sun is covered. And there's an annular eclipse, like what we just saw, where the moon covers the center of the sun, leaves a ring of light around it.
Now, when's the next time we'll get to see a solar eclipse in Cambodia or the Philippines?
Well, unfortunately, we'll have to wait a bit. Because in Cambodia, the next significant solar eclipse will be a partial eclipse on 2nd of August 2027 during sunset. And another partial eclipse will happen on the 22nd of July 2028. That's going to be around morning time, 8 o'clock, which will also be visible in the Philippines at 9 a.m. Well, as for a total eclipse, that's going to be a long time to wait.
That's why we love astronomy. The wait just makes it more exciting when these events finally happen.
Yeah. Well, speaking of waiting, let's now move ahead with the main topic. Let's dive in. So before we talk about the sun's future as a red giant, let's take a look at how stars like the sun are being formed. So here's an image I took of the Orion Nebula. Regions like this in space are where stars are actually born.
Stars form inside these enormous clouds of gas and dust. Gravity pulls hydrogen atoms together until they start nuclear fusion. This is what powers stars, turning hydrogen into helium. That's when the star is officially born.
And stars come in all sizes and colors. We've got massive hot blue stars that burns through their fuel quickly, and there are smaller, cooler red stars that last billions of years longer.
Now, why do blue stars live shorter lives? Well, it's because they burn through their fuel much faster. They are much hotter than red stars and use up their hydrogen supply quickly, so they have shorter lifespan, just a few million years compared to billions for red stars.
And when it comes to planets, people often ask, are there more Goldilocks zones around blue stars or red stars? The truth is, blue stars burn so quickly that any habitable planets wouldn't have enough time to develop life as we know it. However, red stars can have stable Goldilocks zones for billions of years, making them better candidates for habitable planets.
Our sun is what we call a yellow dwarf. But wait, is it really yellow?
Well, good question. The sun actually emits white light. So it looks yellow from Earth because of the atmosphere. Well, it scatters blue light and violet light, so leaving behind that yellowish hue. If you were in space, you'd just see sun as white.
So next time someone asks you what color the sun is, you can drop the science bomb and say it's technically white.
Now, our sun is in the middle of its life, chilling in what's called the main sequence phase. It's been shining for about 4.6 billion years, and it's got another 5 billion to go before things get more interesting.
Yep, once it runs out of hydrogen fuel, it'll puff up into a red giant, possibly swallowing Mercury, Venus, and maybe Earth.
Yikes. As the sun grows, it will boil away Earth's ocean and dry the atmosphere long before it actually reaches our planet.
That's right, no beachfront properties after that.
Yes, good luck to real estate. Okay, let's cut that. But before the sun turns into a red giant, it goes through solar cycles every 11 years.
During solar maximum, we get more sunspots, solar flares, and solar storms. At solar minimum, things quiet down.
So solar cycles don't affect day-to-day weather on Earth much, but they can cause cool phenomena like auroras, those gorgeous northern and southern lights that we see on pictures or on videos. So, to wrap it up, the sun is expanding. Earth might get swallowed, but not for a billion of years. In the meantime, we've got auroras and solar eclipse to enjoy.
Right, by the time the sun swallows Earth, we'll either be long gone or chilling on the same distant planet. But what if there's more waiting for us out there?
Speaking of distant planets and future space travels, how about entire galaxies on a collision course? In the next episode, we'll dive into Andromeda, and trust me, it's coming straight at us.
Yep, it's the ultimate cosmic traffic jam. Andromeda versus the Milky Way. Stay tuned.
Yep, we need you back for more cosmic adventures. Until next time, see you soon, AstroKhampers. So, a Goldilocks zone, also known as the habitable zone, refers to the region around the star where conditions are just right for liquid water to exist on the planet's surface, an essential ingredient for life as we know it.
The name comes from the story of Goldilocks and the three bears, where Goldilocks finds things that are just right, not too hot, not too cold.
So in the context of astronomy, too close to the star and the planet will be too hot, causing water to evaporate.
Too far from the stars, the planet will be too cold, causing water to freeze.
So just right, and the temperature allows liquid water, which could potentially support life.
The location of the star's Goldilocks zones depends on the star's size and temperature. For example, a hot massive blue star will have a wider and more distant Goldilocks zone.
Meanwhile, a cooler red dwarf star will have a closer and narrower Goldilocks zone. Red stars in particular are considered good candidates for hosting habitable planets because their Goldilocks zones remain stable for a billion of years, allowing time for life to potentially develop.